Good morning everyone, my name is Abhinav and I will be your TA for this course. The main goal of this assignment is to take a design from Cadence Virtuoso, export its netlist and then simulate it in the ELDO, followed by plotting of the results in the EZWave. Here is the step-by-step flow we will follow. First we export the netlist from Cadence Virtuoso in form of a .src.net file. Next, we copy this netlist into a separate working directory created for this assignment. Inside this directory, we prepare a .cir file that references the netlist. For this first assignment, the .cir file will be provided to you, so you don't need to write it from scratch. Once the .cir file is ready, we'll run the ELDO simulator on it. ELDO will generate an waveform database file, usually written with an extension .wdb. Finally, we will open this .wdb file in EZWave, which allows us to plot the voltage and current waveforms and analyze the circuit's behavior. So let us begin. I'll close this and I'll go in my DVD folder. You might have a folder named CMOS65. We have to go into the CMOS65 folder and click on Open in Terminal. Now I have to instantiate Virtuoso from here. For this I'll write CSH. After CSH I'll write source dot backslash dot CSHRC underscore CMOS 065. I'll click on enter. Now it's exporting the license for the Cadence environment. We'll wait for few seconds. Now the license has been exported. To initiate the Virtuoso, I'll write Virtuoso into it. Virtuoso. After clicking enter, a terminal should pop up like this. This is the Virtuoso terminal. We'll wait for it. See, it has the Cadence has instantiated. So we'll go into the file. As in the previous tutorial, you must have made the schematic by now. I'll click on open, and for the reference I'll open the schematic. So this is the CMOS inverter that you have made. This is nothing but a PMOS and an NMOS. This is PSVT instance, PSVT LP instance, and this is NSVT LP instance. As you can see, the width of PMOS is twice the width of the NMOS, because the mobility of the ions is less than that of electrons, which is approximately by half. Also, this schematic has four pins: INP, VDD, GND, and out. Of these 4 pins, INP is of input type and VDD is of input type. GND is a bipolar pin and out is an output pin. Now I have to export this schematic in a SRC format, in a netlist. I'll minimize this. I'll come to file. I'll come to export, and the export there is a sub option called CDL. I'll click on the CDL and click on the library browser. Go into that library in which I have made the schematic. For me, that is assignment 01. In this assignment 01, I have 2 cells. I'll click on the cell that I am interested in getting the schematic out, that is INV, and the type is schematic. After this, I'll click close. And now what I have to do, in the output, I have to rename the file. Output CDL netlist. I'll rename the file. I'll name it as video.src.net. Please make sure to rename your file with an extension src.net, as this is very crucial. Now what I'll do, I'll create OK. I'll wait for it. Now this says the job has succeeded. I'll click on OK, close this, and we can see, wait a second please, and we can see that the netlist has generated successfully. To keep my directory clean, what I'll do, I'll create a folder here. I'll rename it as DVD videos. Video. Okay. I'll copy move my src.net to here. Now we open this and create one video src. See, we have opened the src.net, that is instantiated from the circuit. Now what this says, this is the library name, this is the top cell name, this is the view name. View is type of schematic, and this is the today's time and today's date and time. Now this now what does this mean? Dot sub circuit. It gives the information about your circuit. Your cell name is INV. The pins associated with it are GND, INP, out, and VDD. This next line is commented out, but it states the nature of your pin. That is dot pin info. INP is of input type, VDD is of input type, out is of output type, and GND is a bidirectional pin. This is the instance name MMO, and these are the input to your MMO. Now we can see NSVT-LP has a width of 2.44. As we have seen in the schematic, the width of the NMOS is half that of PMOS. Since we are working in 65 nanometer, length is 0.06, and you don't have to worry about anything since ncon and m is equal to 1 plus accurate flow is equal to 0. Same for the PSVT-LP. Now what we will do, we'll edit this file. We'll come here and try to edit it. What you have to basically do is to remove this M and replace it with X. For some reason my keyboard is frozen, I can't do it. Let's see. Can I write X here? Okay, I'll write X here and we'll see if it works or not. Now I have written this. I have to save it. After saving, what I'll do, I'll close it. Now we need an sr.cir file here. For this first assignment, we will be providing you the CIR file. For the time being, I'll copy it from here only. Copy. I'll come to my folder DVD video. Oh, it's open here only. I'll paste it. Now I'll open both the files side by side. Now this is your CIR file, and we have explained each and every line of the CIR file in class tutorial. So you can take a reference and help from the TAs, and you can come in the office hours of the TAs to know more about these. For the time being, to run the simulation, what we have to do, we have to change the name. See, my instance is INV, and here also my instance is INV. So it is not a problem. Now what I have to do is I have to change this also. To change this, let's see if it is editable. Oh, this is not editable for some reason. Okay, no worries. What I will do, I'll take the help from here only. Copy. And I'll paste it here. Paste. Basically these are the same thing. You can see this is exactly same. You can see this is exactly same. As you can see here, the one M has been removed and replaced by capital X, and you have to do the same thing in your src.net that has been exported out. Okay. Now we have a CIR file and we have an src file, and we are ready for simulation. What we'll do, we'll come here, and in the main CMOS folder, I'll open a new terminal, and now I have to invoke the ELDO simulator. For that, what I have to do, I'll write CSH again, enter, source /mentor 2020 /ams.cshrc. I'll enter it. Now the ELDO has been invoked. I'll change my directory to DVD video. Now we can list. These are the files that are present in the directory. To run the simulator, what I'll do, I'll write ELDO and name of the CIR file inv.cir. Now it should run. As you can see, the simulator has ran and we have computed various parameters. As you can see, the rise time and fall time are different here. And the assignment, in the assignment, it might be different here, but in the assignment you have to make the rise time and fall time same. This is just a sample video to demonstrate the working of the tool. Okay. Now once we run the simulator, what we'll do, we'll go into DVD video. As you can see, a database has been created, that is inv.wdb. So let's see how this inv.wdb can be seen or plotted. For this, go to your ELDO simulator, and here, right, you can see where I am, the present working directory, pwd. You can see I am still in the DVD video folder. I'll write ls, and now to see the wave, I'll write EZWave inv.wdb. See, double click on inv. .tran folder will open. Click on it, and you can see stacked, plot stacked. Oh. Okay, we'll delete this. We'll delete all these. We'll delete also. Okay, this is required, and we'll write input also. Now you can see for the if the input, will discard this also. As you can clearly see, when the input is high, the output is low. When the input is low, the output is high. So we have implemented and checked the functionality of the CMOS inverter. So this concludes the tutorial for the ELDO simulators and EZWave. Thank you.